Hello everyone, welcome to GIS Man. I'm Miles Lee. In this video, we will continue to talk about how to program the neural network with Pytorch to help the spatial data prediction. If you didn't watch my previous video, please click on the right top link to watch it. In the last video, we have already built up the structure of our neural network, and we have already normalized the input data from a large value into the value between 0 to 1. So in this video, we will continue to set up our neural network parameters, loss functions, optimizer, and then we will need to train our dataset and use the trained data model to predict the results. So let's begin. Okay, so firstly, we will need to initialize the neural network instance. We will use the class that we defined last time, which is this one. And then after that, we will need to define the optimizer for our neural network. There are lots of algorithms can be chosen. For example, the most common one will be SGD, which is the stochastic gradient descent, which can be used for many general cases. And also there are lots of other algorithms. Each of them has their own advantages. So this time I will use the Adam algorithm. I will explain why it is good for our case. So let's write it first. Adam. So right here we will need to pass our neural network parameters that we defined previously, and we also need to give a learning rate. This value cannot be too high or too small in order to make sure that our neural network can train the data precisely, and also at the same time the speed should be fast. Okay, and then the third parameter we will need to use is the AMS grad. We set it to be true. This parameter is important for Adam algorithm. It can make sure that our loss can be continuously reduced during the training, even though after training for a while. So, and then we will need to set up our loss function. Of course, there are lots of loss function can be chosen as well, but I will use the most common one this time, the mean square loss. You can refer to the official documents on Pytorch website to find other loss function. For example, another very commonly used loss function will be the cross entropy loss. You can try different one to find the best result, but this time I use this one because it can enlarge the errors and make the convergence to be quicker. Okay, and then after that, what we need to do is to turn our previous normalized data into the tensor. Tensor is a very important concept in Pytorch. You can imagine, I mean, it's like a table with a certain number of rows and columns. Okay, so the type will be the floats. Okay, and we do the same thing for our Y dataset. The X dataset is our training factors. The Y dataset is our targets, which we have already talked about this in our last video. So okay, so currently we have the tensor. We can print it out to take a look how it looks like. So we just run it. You see, this is our tensor for our S dataset, which is our training vectors. is of n rows with 3 columns, and for our target value it will be n rows with 1 column. Okay, so next step we are going to train our data and then print the process of our training. So right here, the first thing what we need to do is to define an import value. The import, it means that how many times you would like your neural network to iterate over your training dataset. For example, I just want to iterate over my training dataset for 2000 times so that I can set this value right here. And then we will need to use the for loop to iterate the training dataset with our neural network. And inside each iteration, we will need to do something. Firstly, what we need to do is to use our neural network to predict the values based on our input data. And then after that, we will need to use our logs function just defined to find the difference, to compare the predict value with our target value. Okay, so here we compare our predict value that we predict from our neural network with our correct target value. And then when we get this loss function, we will need to do the backward propagation to calculate the overall weight gradient loss from our neural network. And then this backward propagation calculation will help our optimizer later to update the weight in the next iteration in order to reduce the error. Okay, so here we have our optimizer.step, which to update the weight in the next iterations by getting the calculated results from our logs backward propagation calculation. Oh, before that, each iteration we will need to clear the last optimizer's gradient descent rate. Okay, so we will need to clean this for our optimizer at the beginning of each iteration. Of course, in most of the cases, we will need to see what's going on during the training so that we can print out some information. For example, we will need to print which step it is. And then in this step, what's the loss and error? We will need to see if the accuracy is improving. Okay, so it's right here. We need to pass in our step number and the logs error. Okay, so we can take a look how it goes. So we can print it. At the beginning, we can see the error is quite large, which is 18%, and then each 100 step, we can see the error is reduced. Now it's already been less than around 3%. Okay, so which is good. We can see that while we train the data set, the error of our the predictions reduced from the 18% at the beginning to the end less than 3.1%, which means that our neural network's accuracy is increased. Okay, so the next step what we are going to do is to use our trained neural network model to predict the results for our text dataset. So first thing, as before, we will need to use our Panda to read in our text dataset from CSV file. So which is gnavtest2.csv, and also we will need to remove our column index column. We don't need that. Okay, so it's right here is the data frame panda test equals to our CSV read in data frame. And then we will need to turn our data frame into the NumPy array. And then, as before, what we need to do is to normalize the data from the large value into the value between the 0 and 1. These steps are exactly the same as before. If you didn't watch my previous video, you can go back to watch my previous video. Okay, so currently we've got the normalized data. We can print and take a look to make sure that everything is correct. Okay. So no problem here. The next step is that we will need to split the first 3 columns because that is the data, the vector data that will be used for our neural network model. And then the 4th column we will need to remove it because we will get our predict value. We don't need to have the 4th column. Okay, we just need to use the first 3 columns and then pass them into our neural network model to get our predict value. So what we are going to do is to split the data frame. Let's see how to do that. We need to get all row and then the 0 to 0, 1, 2, 3. Yeah, I will use the length to calculate it automatically. Okay. So which means that this one will get how many columns? Okay, there are 4 columns, and then 4 minus 1, which is 3, which is from 0 to 3 index. Okay, 0, 1, 2. So this is how I did it. And then, just as same as before, we will need to turn these normalized NumPy arrays into the tensor. Just like before, we can copy and paste from here. We need to turn it into the NumPy. Oh, sorry, into the tensor. Okay, we can print it out to take a look. Okay, so now everything's turned into the tensor. So what we are going to do here is to use our neural network to predict the values based on our text data set. Okay, this is the neural network that we trained previously, and then we will pass in our text data set, which is a tensor, with 3 columns, okay, to predict our value. And after that, this step is very important. We can print it out to take a look what's going on here first. So here we got the temporary predict value. Okay, it's also a tensor with 1 column. However, this is a normalized value, which is not the correct value. We need to reverse normalize it and get it back to the real practical and usable value. Okay, so this step is very important and is a little bit tricky. So what we are going to do is to use our test datasets normalize NumPy array, and we just take the last column, which is the column that is going to be store our predict data. Okay. Okay, and then we will take our temporary predict values. Here we will change it back to the NumPy because in this you can see is a NumPy array. Okay, so we will change back our predict temporary value into the NumPy and then reshape it. Okay, reshape it. This is just 1 column. We need to reshape it into the number of rows. 1 column of number of rows. We need to reshape it as a NumPy array and then store it in the last column of our previous normalized NumPy array. Okay. And then what we are going to do is to reverse transform. Reverse transform, this function is in the scikit-learn min-max class, which can help us to reverse normalization to recover these values between 0 to 1 back to its original practical viewer value. So this is the thing we want. Okay, so now we can take a look how it looks like without 2. Okay, we just delete this one. We don't need to use that anymore. And then we just print it. Okay, what we can see, the last column has already been turned into the large number, which is the viewer value. We will need to make it to be more clear and also with the header. So we just do that. We will need to drop our old value from our test dataset, which is not useful because we will use our predict dataset. Okay, axis is 1, which means the column, and then what we are going to do is to rewrite it with our predict value. Okay, let's take a look how to do that. This one we will need to, because previously it's called AADT, the header is called AADT derive. This time we make it a bit different. We said is the AADT derived prediction, which means that we predict this value from our neural network. Okay, so this one we just got the predict value from our results to NumPy array. Okay, we use this 0 minus 1, which is the same as here. It defines, the top column we have in our NumPy array. Then we will also need to make it to the list to turn it to the NumPy array. And then here we get the new values from our predict results. Okay, so now we can take a look how it looks like. PD test new. We print it. We can delete this one. We don't need to use that anymore. Okay, so there's something wrong. Index 4 is out of bounds for x's. Let's take a look. We got some errors. Job AADT derives. Okay, so here I make it a mistake. Just write it wrong. Okay, so now this time should be right. You see, we got the new value. This value is the real value that we reverse normalize from our predict value. So that's it. This video and the last video show how to program the neural network with the Pytorch to do some spatial data analysis and prediction. Actually, it can also be used from other types of data, but not just the spatial data. And in fact, the artificial intelligence, the neural network, and deep learning are very big topics. What I just talk in these two videos is just a piece of iceberg. So if you are interested in such topic, please don't hesitate to comment below, and then we can discuss, learn, and improve together. So thanks for your watching. See you next time. Bye.